All right, okay, you guys. So I do want to review something that I did previously teach you, the rainbow arc, just because it really strongly links to this lesson. This lesson is a fun lesson for me. I know a lot of kids don't think math is fun, but for some reason, I always thought drawing factor trees was fun. I enjoyed it. So that's what this lesson is about: drawing factor trees and coming up with a prime factorization of a number. Um, but in order to be able to do that, we do have to look back on the rainbow arc. So I just want to show you the big difference between a rainbow arc and a prime factorization and drawing a factor tree. So again, it's all going back to knowing the factors of a number, okay? So remember, I said when you're thinking of the factors of a number, you always start off with the actual number itself because you know the number itself, it is divisible by. Every number is divisible by itself. So when I'm doing a rainbow arc, and the only reason I don't call it a rainbow arc is because I don't always use different colors for all the numbers. Like right now, I'm just going to do it with black and not go back and forth with different colors. But it always arcs, so that's why I call it a factor arc. Um, so we know 1 times 24 equals 24. So then again, if you're going with your calculator now, the next step would be you would do 24 divided by 2. But again, if you know your divisibility rules, you would say it's definitely divisible by 2 because it's an even number. So 2 goes into it 12 times. Okay. So again, this goes off of your divisibility rules. So if you know your divisibility rules, you would know that 3 definitely goes into 24. How do I know that? Because remember, anything divisible by 3, if you add up the numbers, it would be divisible by 3, meaning 4 plus 2 is 6. Is 6 divisible by 3? Yes. So since 6 is divisible by 3, that means 24 is divisible by 3. Okay. So 3 goes into 24 8 times. Okay. Now we think about 4. Does 4 go into 24? It sure does. It goes in 6 times. 5, does 5 go into 24? No, because remember divisibility rules. If 5 goes into a number, the number would end in a 0 or a 5. Okay. Then the next number is 6, which we already have, so we know we stop. We don't go any further. So these are your factors of 24. So I'm just going to list my factors. So my factor list is 1, 2, 3, 4, 6, 8, 12, and 24. Remember, they have to be in numerical increasing order. You can't jumble up the numbers. It has to look like that. Okay, so please keep that in mind when you're taking a quiz or an exam. Now I am just going to simply flip my board, and we are now going to discuss prime factor tree, prime factorization. Okay, so how this is different is you put your number at the top. Then you see 2 little branches coming off. So we're saying what times what gives me 24. Now it's your choice. There's many things, right? We just went through the whole factor list. We said 1 times 24, 3. You can use any of these. You could use 8 times 3. You can use 4 times 6. 6 is up to you, okay? Whichever ones you choose, okay? So let's say 8 times 3, okay? And I'll tell you why I'm choosing that in a minute. So this is merely saying 8 times 3 is 24. Why did I choose this one? Because that was the option that gave me, I could have done the 2 and 12 as well, but this was going to get it to me. So 3 is a prime factor. What is prime? Prime is a number that's divisible by 1 and itself. 2 would have made it too tricky, so we're not going to go there. Okay. So 3 is only divisible by 1 in itself, so it's a prime number. 13 is only divisible by 1 in itself, so it's a prime number. So it's any number that's only divisible by 1 in itself is a prime number, okay? Um, so, and if it's not, then it's called a composite number. So 8 is a composite number because it's divisible by more than just 1 in itself. It's divisible by 4, it's divisible by 2. So this is a composite number, this is a prime number. So when you're doing a prime factor tree and you want to find the prime factorization, I always say step 1, you want to circle your prime numbers. So I'm going to take 3 and I'm going to circle it. Another big thing is I always put my prime numbers to the left-hand side to make it easier. So now I want to pull out, I always try to pull out a prime number. So I'm going to say 8, 2, and 4. 2 is a prime number. It's only divisible by 1 in itself. Okay, so I'm going to circle that as a prime number. 4 is a composite number because it's divisible by 1. It's divisible by itself, 4. It's divisible by 2. So it doesn't fit that profile. Okay, so now I got to figure out 4. I'm going to do 2. I want to always pull out my prime numbers times 2, and I circle it. So when I'm circling it, that means it ends. I don't break it down any further. My composite numbers, I can keep going because there's more things that divide into it. 3, there's nothing else I can divide into it. It's divisible by 1 and 3. So there's nothing else I can do with it. It stops. Circling it lets me know I'm done with the number. Same thing, 2, it's a prime number. Lets me know I'm done with the number. I don't need to break down that number anymore. It's done. Okay. So now that I see all my end points are circled. That's why I keep it to the left until it gets to the bottom. I circle my bottom. I see everything is covered. I know my problem's done. So what is my next step? To find my prime factorization, I got to multiply all of my prime numbers. So what I'm going to do is I'm going to come to the bottom and I'm going to say, how many 2's do I have? I have 1, 2, 3. So I'm going to do 2 times 2 times 2. I have 3 2's, and then I have a 3 times 3. Okay. Now that's not simplified. You'll see in my class, it always says with every quiz, give me the most simplified form, the most reduced form. That is the final answer you have to give me. So how many 2's I have? 1, 2, 3. So that's technically 2 cubed times 3. That is your final answer. Okay, 2 cubed times 3. And that's the prime factorization of 24. So 2 cubed times 3 is a prime factorization of 24. And 2 cubed simply means 2 times 2 times 2 times 3. So check, always check your work, see if it works out. 2 times 2 is what? 4. 4 times 2 is what? 8. 8 times 3 is what? 24. Does it circle back to 24? Yeah, so you did it right. If it doesn't equal 24, you did something wrong and we need to go back through it. So that's how you work prime factorization trees. Again, you're trying to pull out all the prime numbers. A prime number is any number that's divisible by 1 and itself only. When you go through my PowerPoint slide, I give you a whole chart of all the prime numbers for you to reference and look at. And this is just a short tutorial of how you create a prime factor tree. Okay, I hope you have a great day. Bye.